Okay, 7a, it says find the eigenvalues and eigenvectors of this matrix. This, guys, is what I call a not easy familiar question. This comes up every year, and if you do 20 of them, you'll be able to do it. So practice this, guys. Make sure you can do this question. It's definitely not a difficult question. So how do I do it? Now, guys, if you want a more detailed explanation of why I'm doing all these things, go check out my video, but I'm going to go through this quite quickly. So it's -4 minus lambda, 0, 3, minus 2 minus lambda. The determinant of this matrix has to equal 0. Again, if you want to know why, check out my video. Determinant of this is this times this minus this times this. So it's -4 minus lambda times -2 minus lambda. -0 times 3, which is just -0, which is just 0, so forget about it. This equals 0. Now I have a nice factorized quadratic, so this equals 0, or this equals 0. So I have lambda equals -4 and lambda equals -2. These are my two eigenvalues. To get the eigenvectors, I need to look at them separately. So I say for lambda equal -4, I have -4, hang on, let's do that again, -4, 3, 0, 2, times some vector xy, this is my eigenvector, has to equal -4 times xy. This is the definition of eigenvalue and eigenvector. And to solve this, I can say, well, look, you can, normally I say just go with the first equation, -4x plus 0y equals -4x. But look what happens, you just get -4x equals -4x. That is not useful. So I go with the second one, which is 3x plus 2y. Sorry, that's a minus, guys, here. Why did I do that? Okay, that's a minus. So it's 3x minus 2y equals -4y. So this times this plus this times this has to equal this times this, which gives me 3x equals -2y. So an eigenvector, so x is -2 over 3y, if you like. Therefore, eigenvector is, again, let y equal to something. It's nice to, like, there's an infinite number of eigenvectors, guys, but it's nice to keep the most simple one you could use. Normally I'd say let y equal 1, but that's going to give me -2/3, which is a nice 2 will give me -4/3. If I let y equal 3, that will give me a nice x. If y is 3, these cancel, x is -2. So that's an eigenvector. For lambda equals -2, same thing. Lambda equals -2. Same thing, I have -4, 3, 0, -2 times some vector, let's use x and y again, equals -2 times this eigenvector. Now I have -4x, -4, if I use the top line, I get -4x plus -4x plus 0y equals -2x. Okay, so here I actually have -4x equals -2x. So we know there's only one solution here. X has to be 0. So x is equal to 0. And then if I use the bottom line, I have 3x minus 2y is equal to 3x minus 2y is equal to minus 2y. I mean, again, here you're just going to get 3x equals 0, x equals 0. But if x equals 0, I can use any eigenvector I want. I can use any eigenvector that has an x as 0. So that's 0. I may as well just choose 1. So my eigenvalues, let's just do, all right, eigenvalues are, eigenvalues, lambda 1 equals -4, lambda 2 equals -2, and eigenvectors, and I'll write corresponding, let me just write it here, corresponding eigenvectors. When I say corresponding, because with the -4, the eigenvector is -2, 3, -2, 3, and with the eigenvalue -2, the eigenvector is 0, 1. Okay, that's it. As I say, guys, it's not difficult, but it's not easy. But it's definitely the type of question that everybody should and can do. Okay, that's part A. I'll do part B in the next video.